Dear students, today I want to revise the second part of work power energy. The topics center of mass and the collision. The center of mass, the point where the whole mass is supposed to be concentrated. You should know for symmetrical bodies it coincides with the geometrical center. If you just take a circle, a cylinder or a cone, you can say the center of mass is geometrical center, and it may be within or outside the system. That depends upon the structure, the shape, the distribution of mass. Its position vector changes in translatory motion, but it is constant in rotatory motion. The motion of the center of mass is independent of internal forces. That may be the very, very important point, but depends on the external forces. If a cracker explodes in air, it is due to the purely internal forces, and hence the path is unaffected. It will continue the parabolic path. Look, the very important concept, how we can mathematically express the location of the position vector of center of mass. It's a ratio of the sum of the moment of each particle constituting the system to the total mass. So M1R1 plus M2R2 plus etc. Mn by Mn plus M2 plus etc. Mn. We can go with a simple example. 3 particles of mass 1 kilogram, 2 kilogram and 3 kilogram are placed at the corners A, B and C respectively of an equilateral triangle ABC of edge 1 meter. Find the distance of their center of mass from A. At first you have to find the coordinates of the point of the masses A, B and C. Then you have to substitute in the equation for x center of mass Ma xa plus Mp xb plus Mc xc by Ma plus Mb plus Mc, or a y center of mass Ma Ya plus Mb Yb plus Mc Yc by Ma plus Mb plus Mc. So you just substituting the coordinates, you get the value. X center of mass as 2 by 3, the y center of mass as root 3 by 6. So the position vector can be write as 2 by 3 I plus root 3 by 6 j. Therefore, the distance is equal to root of 2 by 3 the whole square plus root 3 by 6 the whole square. You get the value equal to root 19 by 6 meter. Look the very important formula of a two-particle system. Two particles M1 and M2 are separated by a distance r apart. If the location of the center of mass is at a point R1 from M1 and R2 from M2, then R1 can be write as M2 by M1 plus M2 into the total separation R, and R2 equal to the second mass M1 by M1 plus M2 into R. If for a two-particle system, if the center of mass lies at the origin, we can say sigma mi ri equal to 0. M1 R1 plus M2 R2. M1 R1 should equal to M2 R2. See, one or two simple questions. Two particles of masses 1 kilogram and 2 kilogram are located at x is equal to 0 and x is equal to 3 meter. find the position of their center of mass. The simple concept we already know, the second mass by the total mass into the total separation. So here the second mass 2 by the total mass 1 plus 2 into. So you get the answer as 2. Look at the next very good question. Two particles of mass 2 kg and 4 kg lie on the same line. If 4 kg is displaced rightwards by 5 meter, then by what distance 2 kg should be moved, for which the center of mass will remain at the same position? You can use this concept. M on R1 should equal to M to R2. Here M on X equal to M to Y. So 2 into X should equal to 4 into 5. So you get the answer as X is equal to 10. Look the another type, the center of mass of continuous distribution of mass. The formula become integral R dm by integral dm, or the total mass. It's a very important point. We can go with one example. A rod of length L is placed along the x-axis between x is equal to 0 and x is equal to L. The linear density of the rod varies with the distance x from the origin as lambda equal to Rx. Then find the position of center of mass. So just to draw the figure. So x is equal to 0 to x is equal to L. You can take a small element dx with the mass dm at a separation x from origin. So you can easily write the expression integral 0 to L x dm by integral 0 to L dm. But you should express that dm in terms of dx. For that you can use the linear density concept. So dm is equal to lambda into dx, where lambda is Rx dx. So just substitution. Just take the constant R outside and integrate integral 0 to L x square dx by integral 0 to L x dx. So it becomes of the form, you get the answer. Look another concept. Find the coordinates of the center of mass of a quarter ring of radius r placed in the first quadrant of a Cartesian coordinate system with the center at origin. So here, just to go through the figure, so here the coordinates are xc and yc. So C is the center of mass location, and if the total angle here is 90, so the half angle is a theta here, then you can use by the concept OC is nothing but is equal to R sine theta by theta. It's a very important concept. If you know that, you get the answer. So OC is 2 root 2 R by pi. Then you can easily find the value of x and y. So it's a very important concept. Look, some important formulas for center of mass. For a semicircular ring, from center 2 R by pi. For a disk, 4 by 3 R pi. Hemispherical shell, R by 2. Solid cone, H by 4. Solid hemisphere, 3 by 8 R. Hollow cone, H by 3. For a circular arc, sector of a circular plate. So it's a very important formulas. We are arrived with a very important concept. How we can find the center of mass of bodies with the cavities. You can use the simple formula m on x1 minus m2 x2 by m1 minus m2. The very important one here, 1, 2, meaning the 1 for the whole mass and 2 for the cutout mass. It is very important. Then what is x1 and x2? Meaning they are the location of the center of mass from a common origin. Keep in mind 1 for the whole mass and 2 for the cutout mass. For a two-dimensional objects, you can replace that mass by area, keep in mind, and for three-dimensional, the mass by the volume. We can go with one good question. A disk of radius r is cut off from a uniform thin sheet of metal. A circular hole of radius r by 2 is now cut out from the disk. With the hole being tangent to the rim of the disk, find the distance of center of mass from the center of the original disk. So you can use this equation as m1 y1 minus m2 y2 by m1 minus m2. m1 we can say the whole mass. Then what about the m2? We can easily find from the concept of surface density as mass by area for the plane sheet. That should be equal to, for the cutout also, that is m2 by pi into its area, pi r by 2 square. Then what is y1 and y2? It is so simple. For the whole one, if you take the origin at O, then y1 is 0. And the location of the cutout mass, its center of mass began. It is at r by 2 location. So just substitution for the first coordinate becomes 0. Next one is r by 2. You get the answer. Why negative sign? It is shifted downward. The center of mass of a composite body is a very important concept. Find the position of center of mass of the figure shown below. It's two objects, a rectangular plate and here a half disc. So we can convert them into point particles by taking the center of mass concept. A, the center of mass of a semicircular disc, and C, the center of mass of a rectangular plate having side 2r. So these are the very important concepts. At first, find out the position of center of mass of both the semicircular plate and rectangular plate. Then find the center of mass of the structure Z. So here the two particles A and C at a separation r plus 4r by pi. So 4r by pi as the center of mass of a semicircular disc. And you can take the mass of A is what? It's a surface density into area. And similarly for the rectangular plate as a C. So you can use the simple concept. The second mass. So suppose you need to find the location of the center of mass from C. So that is the other mass, ma by the total mass into the total separation. So you get the answer. You should know the meaning of center of gravity. The point where the whole mass of the system is, the weight of the body is supposed to be concentrated. And keep in mind, for flat surfaces, the center of gravity coincides with the center of mass. But for extended objects like mountains, the center of gravity lies below the center of mass. Look, the very important concepts of the velocity of the center of mass and acceleration of the center of mass, the similar structural formula like that of the position vector. Very good aspect. You can go through some important questions. A good concept, good concept. A flat car of mass m is at rest on a frictionless floor with a child of mass m standing at its edge. If the child jumps off from the car towards the right with an initial velocity u with respect to the car, keep in mind, with an initial velocity u with respect to the car, then find the velocity of the car after its jump. Look, the steps so clearly. Let the car attains a velocity v. The net velocity of the child with respect to the earth will be u minus v. As u is its velocity with respect to car, therefore the velocity becomes u minus v. So look the figure. So v is the velocity attained by the car. So initially the system was at rest. Thus, according to momentum conservation, before and after should same. So we can write the answer. Next question. Figure shows two blocks of masses of 5 and 2 kg placed on a frictionless surface and connected with a spring. An external kick gives a velocity 14 meter per second to the heavier block in the direction of lighter one. Then deduce, we have to answer for two questions, the velocity gained by the center of mass. The separate values, velocities of the two blocks in the center of mass coordinates just after the kick. So we can say the velocity of the center of mass is m1 v1 plus m2 v2 by m1 plus m2. So here the one object is at rest. So you get the answer. Look the concept. Due to kick on 5 kg block, it starts moving with a velocity of 40 meter per second immediately. But due to inertia, 2 kg block remains at rest at that moment. Therefore, the velocity of 5 kg with respect to center of mass become, look the steps, 14 minus 10. The 10 is nothing but the velocity of the center of mass. You get the answer 4. What is the velocity of the 2 kg with respect to the center of mass? So you get the answer minus 10 meter per second. Look the very important question. A man of mass 80 kg stands on a plank of mass of 40 kg. The plank is lying on a smooth horizontal floor. Initially, both are at rest. The man starts walking on the plank towards north and stops after moving a distance of 6 meters. Then, the choices are the plank will slide to the north by a distance of 4 meters. By a distance of 6 meters, towards south at a distance of 4 meters, 12 meters. So what is the answer behind? A good aspect. Look the figure carefully. The center of mass remains stationary if it is external. If it is internal force. If it is internal. Let x be the displacement of the plank. We can simply write 80 into 6 minus x equal to 40 into x. m1 r1 should equal to m2 r2. You get the answer. Again, you are waiting a previous year question. Good question. Two bodies of masses m1 and m2 are connected to the ends of a massless cord and allowed to move as shown in figure. The pulley is massless, frictionless. Calculate the acceleration of the center of mass. So look here, and it is given that m1 is greater. So if m1 is greater than plus a, then m2 should be minus. So simply you can say the acceleration of the center of mass is what? m1 a1 plus m2 a2 by m1 plus m2. But what is a? You know, for a pulley system it is m1 minus m2 by m1 plus m2 into d. So that is the answer, maybe a good concept. Collision of bodies, a very important concept. A collision is said to take place when either two bodies physically collide against each other or when the path of one body is changed by the influence of the other. Keep in mind, we can divide that collision of bodies into two categories. According to the direction of collision, we can say head-on collision and oblique collision. Look the figures. Before and after collision, it will happen along a line, we can say head-on collision. At an angle, we can say it is a oblique collision. But in your mind, according to law of conservations, we can divide as elastic collision, inelastic collision, and perfect inelastic collision. And keep in mind for a collision, elastic, we can say the momentum is conserved, the kinetic energy is conserved. Keep in mind that conservation only before and after, not at the moment of collision. For an inelastic collision, The momentum is conserved, okay, but kinetic energy is not conserved. The kinetic energy after is less compared to before. Some sort of energy is lost as heat. The perfect inelastic collision. And here the momentum is conserved, kinetic energy not, but the two bodies stick together after collision. It is a very important concept. Look at some important formulas. At first one, the coefficient of restitution. It is the ratio, the impulse of recovery by the impulse of deformation. The best one, the velocity of separation by the velocity of approach. And keep in mind that value of E is equal to 1 for elastic collision, equal to 0 for perfectly inelastic. And inelastic collision, 0 less than E less than 1. Look, the very important concept, the head-on elastic collision. So the two bodies A and B, after collision, they move on the same line. Say its initial velocity before collision are u1 u2, but after collision it becomes v1 v2. Conservation of momentum, the first concept. Before collision m1 u1 plus m2 u2. After collision m1 v1 plus m2 v2. You can take for m1, so you get the value. And again for the conservation of energy, you can write the half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. You can take that equation. So that is a very important concept. By using that concept, that is Newton's law, in one-dimensional elastic collision, the velocity of approach before collision is equal to the velocity of approach before collision is equal to the velocity of recession after collision, no matter what the masses of the colliding particles be. The very important Newton's concept. By using that concept, we can derive the relation for after collision what is V1 and what is V2. Look the equation, it should be in our mind. So V1 equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2, and V2 equal to 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2. Look the three important cases. It is the just sub cases of this equation. What happened if both the masses become equal? Look the very important concept. After collision, exchange their velocities. It is a very important concept. Look the point here. If the second body is initially at rest, then what happened? It is very important. The body A comes to rest and the body B moves the velocity of A. The very important concept. We can move with a good question. Two ball bearings masses 5 kg each is moving in opposite directions with equal speed of 5 meters per second, collides head on with each other. Find out the final velocity of the ball if collision is elastic. Collision is elastic. What is the meaning of elastic collision? Kinetic energy, the momentum are conserved, and hence we can say the velocity get interchanged because they got the same mass. So for the second mass got the initial mass 5 meter per second, and the first one got minus 5, the opposite direction. Look the next concept. What do you mean by? One more question. A ball of 0.1 kilogram makes an elastic head-on collision with a ball of unknown mass that is initially at rest. If the 0.1 kilogram ball rebounds at the 1/3 of its original speed, then what is the mass of the other ball? You can use this concept. Then you know is u2 is a 0. The v1 is given as minus u by 3. So just substitution, you get the answer. A good aspect. Look, the head-on inelastic collision of two particles. Keep in mind the momentum is conserved, kinetic energy is not conserved. Then according to Newton's law we can substitute, and that implies a V as V2 minus V1 by U2 minus V1. So then you get the equation. So look, what is V1, what is V2, how that relations changes with respect to elastic collision. It is very important. So here V1 equal to M1 minus EM2 by M1 plus M2 into U1. M2 into 1 plus E by M1 plus M2 into U2. Then V2 equal to M2 minus E M1 by M1 plus M2 into U2 plus M1 into 1 plus E by M1 plus M2 into U1. See, look, what do you mean by perfect inelastic collision? After collision they stick together, or the two bodies move with the same velocity. That is a concept there. So momentum conservation, M1 U1 plus M2 U2 equal to M1 plus M2 into V. So you get the concept for velocity by using the kinetic energy initial, half M1 U1 square plus half M2 V2 square. The kinetic energy final become half into, the bodies are sticks together, so M1 plus M2 into, they are moves with the common velocity as V square. So loss in kinetic energy we get the very important concept as half M1 M2 by M1 plus M2 into U1 minus U2 the whole square. We can express in terms of the reduced mass, and U1 minus U2 is the relative velocity. Look, if the target is initially at rest, delta K, the change in kinetic energy become of the form. If the target is massive, like collision with a wall, the percentage loss become 100%. The very important concept, elastic collision in two dimensions. Look, the steps we have to use to solve the problems relating to two-dimensional collision. So after collision, their velocity directions may match an angles theta 1, theta 2. What are the procedures we have to do? So at first one, for elastic collision, the conservation of energy. Okay, you can use that concept. But that velocities can be split into vertical and horizontal directions. And keep in mind the momentum is conserved not only along x-axis but also z-axis. Here, before the collision there is no y component, and hence we can say 0 equal to the y component we can take considering, and similarly x along x. These 3-4 factors, that is a very important concept. Total energy remains conserved in all type of collision. Total energy. Only conservative forces works in elastic collision. See the another concept, the line of collision. Line along which the normal contact force acts is called line of collision. It is independent of the direction of velocity of colliding bodies. After collision, that's a very important point, only the components of velocity along line of collision changes. The perpendicular component of velocity remains unaffected. Some previous year questions are based on that concept. Very, very important. Look at the question. A ball is dropped freely from height h. The ball is continuously rebounding. Then find out velocity of the ball after n rebound, height attained after n impacts, the total distance covered by the ball before it stops rebounding, total time taken by the ball, total momentum transferred. Very good questions, very good questions. We can use the simple Newton's formula. The V2 minus V1 is equal to E into U1 minus U2. So the first dropped one, the velocity gained is root 2 gh. For the second case, we can write V1 equal to EV, but V1 is equal to U1. So we can substitute it for that E1, V1. So you get the value. So V2 equal to E square into V. So V3 equal to E cube into V. V4 equal to E raised to 4. So nth velocity, E raised to n into root 2 gh. By using the same concept, we can attain the equation for height. V1 is root 2g h1 equal to E times root 2g h. But h1 is equal to E square h. And again, V2 is equal to E square V. Again, we can substitute. So hn is equal to E raised to 1h. How we can find the total distance? Yes, the same two distances are there. And hence h plus 2h1 plus 2h2 plus, yes, goes on to infinity. So you can just substitute the relevant relations. Yes, you can use the simple geometrical progression to get the answer. And the next option, what is the total time? We know the concept h1 is equal to E square h, but h we can convert it into time. Half g t1 square equal to E square and half g t square. Then following the same method, then how we can find the total time? The initial plus, then 2t1, like 2h1 plus 2h2. Here 2t1 plus 2t2. Just a substitution. Very, very good concept. How we can find the momentum? Similar way. If a body is fall on the surface and rebound, we can easily find, if it is with same velocity, we know 2mv. But here the different velocity, and hence it is written as m into v0 plus v1. So we can move with the same concept and you get the very, very important answer. We can move with the some questions again. A simple pendulum of length 1 meter has a wooden bob of mass 1 kilogram. It is struck by a bullet of mass 10 raised to minus 2 kilogram, moving with a speed of 2 into 10 square meter per second. The bullet gets embedded into the bob. Obtain the height to which the bob rises before swinging back. So you can just conservation of momentum, you get the value V. And that kinetic energy is utilized to increase in the potential energy, you get the value. A ball of mass m hits a floor with a speed v, making an angle of incidence theta equal to 45 with the normal to the floor. If v equal to half, find the speed of the reflected ball and the angle of reflection. An all India PMT question. Look the steps. Since the floor exerts a force on the ball along the normal during the collision, so the horizontal component of velocity remains same. Only the vertical component changes. So the horizontal component, so v dash sine theta dash is equal to v sine theta, you get the value. Vertical component we can say as v dash cos theta is ev cos theta. So on solving you get the value. Another good question. A ball of mass 2 kg moving with a speed of 5 meter per second collides directly with another ball of mass 3 kg moving in the same direction with the same speed of 4 meter per second. The coefficient of restitution is 2/3. Find the velocities after collision. You can use the conservation of momentum, and by definition of Newton's law for collision, E equal to V2 minus V1 by U1 minus U2. You get two relations, solve it. So the work power energy maybe the base for most of the questions in mechanics. So give enough concentration for such a topic. Have to do maximum MCQs. Then you can tackle so easily our JEE or NEET or KEAM entrance exam. God bless you. Thank you.